So we've learned a lot about building with VEX materials in our years of computing, and I figured that would only be right for us to share it. So I'm just going to go over a couple things we've learned about how to build sturdy, consistent robots, and just general build quality things. So the first thing I've learned is you really only want to use C channels and angles. If you look at a robot, I don't know of any. I think actually, wait, we have one plate on the bot, and that's for non-structural things. So use C channels to build because this is a plate. You can just easily just like fold it in half. It's not all that sturdy. Whereas a C channel, even though I have a lot more leverage here, 'cause it's longer, you cannot bend it at all. So they're also a lot lighter than plates. So yeah, use C channels. They are really good for building. And yeah, next thing is you want to use triangles for your intakes and things. Not because triangle is the strongest shape, but because it does not shift just by the nature of the way triangles work. Because for intakes, you want the bearings or the whatever they're called. You want them to be lined up as straight as possible. That way, there's no like friction or anything like that that slows it down. And that's how we got our intakes so smooth. It's no friction at all. This is it's like 4 rollers, and the motor barely has to work to spin it at all. That's because we have our bearings, pillow blocks, whatever, lined up perfectly. And the reason they don't move is because our intake is set up as a triangle here. Because with squares, they work as a 4-bar mechanism, basically. So you can, remember how to do this. They can shift super easily. So if you had an intake shaft going through this, it's about the same size. It's just gonna shift like crazy. So you'd have to run at like 200 RPM at most. You're not going to get any. There's going to be way too much friction. But with a triangle, it just by nature of how it works, even it just will not move. Just because that's how triangles work. So that way, since it doesn't shift, that's how you can keep everything lined up perfectly. That's also why triangle bracing is super helpful. And yeah, so triangles are really good for intakes, just because they keep all the axles lined up perfect. And yeah, that's how we're able to get this intake so smooth. Next thing, I'd say only use aluminum if you can. If you look, we have basically all aluminum here. We have 2 steel C channels here. That's because we ran out of this length. And I just didn't want to replace it because the robot worked. Because they're roughly the same strength. I'd say the steel ones are slightly stronger, but strength to weight, the aluminum's it's so much better because the steel weighs so much more. Like this robot weighs 25 pounds maybe? I don't know. I'm not sure exactly how much it would weigh, but I think it'd weigh about 2-3 times as much if we used all steel, just because steel is about, let's see, I think it's about 3-4 times denser and heavier, whereas it's only twice as strong. So yeah, so if we have steel C channel, even though it has holes in it, it's about 0.26 pounds. A aluminum C channel is about 0.1. So if you were to use aluminum, you get it's twice as light. It's about the same strength, and it's also a lot easier to drill. Next thing I will go over is standoffs. If you look, we use a lot of standoffs here on this robot. That's because they're so good. They're very good. They resist bending a lot. If something bends, it'll be the C channel bending, not the standoff bending. So if you look, we have standoffs everywhere. They're so good to link them horizontally, to link C channels and stuff horizontally. The other thing they're super helpful for is I've seen people have done a drivetrain setup kind of like this, where they have a motor on top, except they use plates instead of a C channel here. I'm not sure how well you can see it, but but I don't know, I'm not sure. Probably can't see it, but we have a C-channel, 5 long C-channel right here, and then standoffs connecting it to this bottom rail here. This is, and we have it on the other side here too. It's really good. It holds the motor super well. It's basically like making the C-channel taller, whereas if you were to use plates here, I've seen a couple people do this, it's not the best idea because it's theoretically a little bit stronger up and down just because of how this is set up, but any side-to-side loading, any force side-to-side, and it's just going to bend and get your drivetrain all out of alignment. So yeah, standoffs are like magic. They're so good. I mean, they don't seem all that strong, but they really are. They help for putting, like connecting C-channels to each other side to side. I guess like spacers would. And yeah, so they're, except they're stronger than screws. So they're really good. Yeah, anyway, they're very good. We use them a lot, and yeah, standoffs and C-channels together like this instead of plates. That's usually a good rule of thumb. It's a very good way to keep everything strong, and that's why this robot was so consistent as opposed to the one from last year. Last year I used like plates and stuff. This year I'm using standoffs, and that's why it's so consistent. Yeah, so to recap, first thing is you want to use C-channels over plates because plates bend very easily. C-channels don't. Next is you want to just use triangles mainly for intakes and things. It's not all that helpful for drivetrain, but it can be just because squares shift, they act like a 4-bar mechanism, whereas triangles don't. They can't shift. The only shifting you'll get is if the screw slides like this. I'm not sure how well you can see it. And then you want to use you want to use aluminum, not steel, because aluminum is the same strength as steel C-channels, except they're twice as light. And then just use standoffs. They're so good. They're just like, they're absolute magic. They're amazing. They're really good. Yeah, so that's what we've learned so far. There may be other things that we missed, and some of the things I said not to do, it could work in some situations, could work for you. But yeah, this is what I've learned so far, and this is what's helped me make this robot super consistent. And yeah, I hope that really helps. And yeah.